Okay, so I realized last night that as I was going through my little spiel, I forgot to share the calculator screen with you guys. So you have no idea what I was doing on that video. So I want to start over again. And I'm going to repost the video with the calculator on it. What I thought I'd do this last week, first of all, it's been fun, like working with you, having you in class, as weird as this semester has been. Um, and it's just been really different. But so what I've decided to do with our very last week, this is our last week together because you don't have a final, so that's it. Um, what I thought I would do is I'm going to give you guys, an optional assignment. So basically, because I don't know who's taking the final and I don't know who's not. So um, I'm going to give you an optional assignment, which is real simple, is to make a study sheet for your 1325 final. One of the best things you can do is like write down the stuff you need to know. And for me, a study sheet should be, at least one side of an 8.5 by 11 piece of paper, with a normal size handwriting. Um, you want to put things on there that maybe you're not too sure about or you've forgotten. Some suggestions. These are just suggestions off the top of my head. There may be more. We'll talk about that. But some things you can write. We started off, I think, with limits. So, is there anything about limits you need to write down? Maybe the different types of discontinuities. Remember, you had a jump or a hole. And you had vertical asymptotes and how to find those, and the limit definition of a derivative. There were two of them that we went over: the slope of the secant line, equation of a secant line, and a tangent line. So average rate of change. So those were all things that we went over before we even got to derivatives. Derivatives, you might want to put all your derivative rules down, the ones you don't know: product, quotient, chain, the derivative ln, whatever it is, put it down. After we worked on all the derivative rules, or you worked on all the derivative rules, we did applications. So what I do there is, if maybe I forgot how to do implicit differentiation, I'm going to put an example in my paper of how to do that. Maybe related rates, maybe optimization. How do you find a relative minimum or maximum? How do you find an absolute? So minimum or maximum, what's the difference? So those are things that I would suggest. With integration, you could put all your integration formulas. Um, you could put all your business formulas, right? Marginal versus average. And so there's a lot of things you could put on that sheet. Basically, these should all look different. So nobody should have the same sheet because you're all unique individuals. But the idea is to put the things that, not the things you know, but the things you need to know. So there's some ideas for what can go on that sheet. So the idea is to give you something concrete that you can study from. The ways that you can get the various formulas is look through your 1325 note and start making a list. If you look at something, you go, I didn't think I knew that, maybe I should write that down. You can also, if you have a book, you can go through the chapters in the book. But anyway, so those are some things that you can do. And like I said, the study sheet is optional. It'll replace the class grade. I'm just giving you an option for a replacement grade. It's completely up to you. If you do it, take a picture, put it in a PDF form using Cam Scanner or something else, and upload it to the Dropbox that I've hopefully put up there or will put up there. All right, and so like I said, this is our last week. I thought I'd just kind of start off today just talking about a definite integral and kind of how to use them in some calculator tricks, because I figure, if you're taking a final, it's probably going to be multiple choice. And so a calculator can probably go a long way toward helping you at least check your answers if you have to show work. But if you don't, a calculator is a great thing. So let's talk about a definite integral. A definite integral, you were doing indefinite integrals. Remember, an integral is the opposite of a derivative. So, you were doing things like x squared minus 2x. If I integrate that, I'm going to raise the power and divide by what I raise it to. So 1/3 x cubed. And this one would be x squared. If I divide by 2, this 2 will go away. So there's my antiderivative. Remember, you put a plus c. This is called an indefinite integral, all right? The indefinite integrals, they don't have the numbers on the limits, they just have a plus c you have to put in the end. I can change this ever so slightly and make this a definite integral. A definite integral, I'll just do one and then we'll talk about what it means. We'll go from 1 to 3. We'll do the same integral. So a definite integral has limits. It has these numbers here called limits, 1 and 3, and what it represents is the signed area under a curve. So whatever this looks like, in fact, I could draw it. Let's see, x times x minus 2. I'm just drawing it out of my head, but it's going to look something like this. And here's 2 here, and I'm going to go from 1 to 3. I don't know where 1 is. So basically what an integral represents is the signed area under a curve. So from 1 to 3, if I could know the area, this area and this area. And what I mean by signed area is the part under the x-axis is negative and the part over the x-axis is positive, all right? So an integral is a signed area under curve. It also is a net change, which we'll talk about with applications to business, but the idea is how much did the function go up or down during that time. All right, so to do a definite integral, all you do is you do your indefinite integral. So I get 1/3 x cubed minus x squared. Now, I don't put a plus c. What I do is I put my limits here with a line. I go from x equals 1 to 3. And all I have to do, whoops, that's a cube, is plug in 3. And this is called the upper limit here, and this is the lower limit. You're going to do the upper minus the lower. So you're going to plug in 3. So it's 1/3 times 3 cubed minus 3 squared, there's the upper limit, minus the lower limit. Now I'm going to plug in 1 in parentheses, so it's 1/3 times 1 cubed minus 1 squared, okay? All right, so now we just got to do the math. So the upper limit, let's see, this is going to be 27 over 3, it's going to be 9, is that right? Yeah, 9 minus 9, okay. The upper limit is 0, interesting. Yeah. All right, minus the lower limit in parentheses. Please don't forget the parentheses. It's 1/3 minus 1. All right, well, 1/3 minus 1 is negative 2/3, but I'm making that negative from here, so it becomes a positive 2/3. So this would be the signed area under the curve. Now, your calculator can do a definite integral. It has that ability, and I'll show you 2 ways to do it. And we're integrating from 1 to 3. I'm writing this down. All right, so I'm gonna stop this for now. I'm gonna clear it. So remember our answer was 2/3. So I'm gonna go, I'm gonna have to stop share. No, let's do new share. Yeah, there we go. All right, so hopefully you can see my calculator now, and there's 2 ways to do this. We'll look at the graph first. So we're going to y equals, let me clear this stuff out here. And we're going to enter the x squared minus 2x. We'll graph it. I'll hit zoom 6. It's a pretty basic graph. All right, and so you see it goes negative and positive. And so the calculator, the grapher can do an integral the way that you do it. You do second, trace, see number 7. Look, there's your integral, 7. And lower limit. So the lower limit of that integral was 1, so you just type 1 and press enter. Then it comes back, it says upper limit. Well, my upper limit was 3, so I press 3 and I type enter. And it shades the area, and guess what it got? It got 0.66666 or whatever, 2/3, okay? So remember, it's the signed area. It's going to be this negative area plus this positive area, okay? The calculator, so the grapher does it for you. Another way to do an integral without graphing, if you go math, and if you look at number 9, it says fn_int, that function integration. So we're going to pick number 9. And this fancy integral sign comes up on my calculator. Now remember, this only does definite integrals. We have to have limits. So we're going from 1 to 3 of x squared minus 2x. So I'm just going to type the function. Dx. And then I'm going to hit enter. And lo and behold, there's my integral. If I want to convert it to a fraction, math, frac, And there it is. All right, so you have a nice definite integral doer on your calculator. So a lot of these don't have to be done by hand unless they specifically ask you to do it by hand. All right, now one of the other things that we're interested in, let me get back to the whiteboard. I guess I'll close this for now. We'll come back and share it later. All right. Okay. Still recording. So I'm going to share a whiteboard with you right now. So another type of problem you'll see that this is what we just did. They want you to find the area between the x-axis and f of x over an interval. So find the area. Now, it depends on the curve. I mean, what we're going to do, we'll look at a really simple one that he had in his notes. He had f of x equals 4x minus 7. And I want to find the area and it between that and the x-axis from the interval was 5 to 10. Okay. So I'm going to use the calculator because the area is just the integral as long as it doesn't go negative, which we'll talk about in a minute. So I'm going to share a calculator with you once again. Let's close that and we'll do new share. And my calculator is missing. Let's see, TI Smart View. Well, hold on a second. There it comes. There's my calculator. All right, let me get this shared with you guys. There we go. New share. Where's the calculator? Let's try it again. New share. There it is. All right, so you can do it by hand, but you can also just integrate it. But make sure it doesn't go negative. So I'm gonna type the function. The function we were looking at was 4x minus 7. And the window we were interested in was x between 5 and 10. So I'm just going to change my window to go from 5 to 10. And then I'm going to hit graph. Okay, and I can't see it. I've got to adjust my window. All right, so I got to adjust the y. So we're going to go a lot bigger with y, I think. Let's go to 30, 40. I don't know, 40. Let's see how that works. Just a guess. Oh, there it is. Okay, so there's my line. Now you can see that line is entirely above the x-axis, so just integrating it will give you the area under the curve. I'm going to integrate from 5 to 10. So because I have the grapher up, I'll just do it graphically. Sorry, second quit. I'm going to do second trace, integral number 7. Lower limit is 5, and upper limit was 10. All right, it comes back with the area under that curve is 115 units. All right. Now, there's nothing wrong with also just doing the math 9 thing. Excuse me, math 9. We're going to integrate from 5 to 10 of 4x minus 7 dx. And enter. All right, I get the same answer. All right, now what you have to be careful of is sometimes curves go negative. So if they want the area between that and the x-axis, you have to kind of split it up. So let me get a whiteboard out with you. New share a whiteboard. Okay, so let's say that now you were given the curve. Let's clear everything. Let's say you wanted the area between the x-axis and the curve of y equals x cubed minus 4x on the interval from 0 to 4. Now, I'm going to graph this, and we're going to look at this and see how we can fix it. All right, so I'm going to share a calculator with you. There's my calculator. All right, so I'm going to graph this function because we have to be concerned. If it goes negative, we have to deal with that. So let's see, it's x cubed minus 4x. Is that right? Yep, minus 4x. On the interval from 0 to 4. So I'm going to change my x to start at 0 and go to 4. I'm only looking at that interval. All right, I'm going to graph it. All right, and maybe I'll make the y a little bigger because we can't quite see the end of it. Let's go all the way up to 50. All right, so now I can see the whole curve. The problem is between the x-axis, if I just integrate from 0 to 4, this area right in here is going to be negative from 0 to 2. Now there's two ways to deal with that. The first is to go second calc. You're going to integrate only from 0 to 2, lower limit 0, upper limit 2, and that area is negative 4, but I don't care about the negative sign. I just know that there's 4 units underneath that area. So that would be the first piece. Keep that in mind. That's 4. And now we're going to do another integral from 2 to 4. Lower limit 2, upper limit 4. Okay, so this particular area is 36. So if I add the two pieces together, 36 plus 4 is 40. So the area underneath that curve is 40. So is there an easier way to deal with this? And the answer is yeah. Okay, so what you're going to do is whatever function you're finding the area between the curve and the x-axis of, if you take the absolute value of it, let's do that. So I'm going to show you how to do that. You're going to hit Math and Num. You're going to go to Num, ABS, number 1, absolute value. And I'm going to type the function I wanted to find the under the area under the axis. It was, oh, I forgot. X cubed minus 4x. All right, so x cubed minus 4x. Now, look what happens when I graph the absolute value. It takes that negative piece and makes it positive. So I don't have to worry about the sign anymore. Now I can just integrate straight from 0 to 4. So if you want to get rid of that negative piece, take the absolute value. All right, so second, trace, and we're going to integrate, and we're going to start at 0 now and go to 4 for the upper limit. And it should give me 40, right? That was the area under the curve. So if they want the area between the function and the x-axis, feel free to just take the absolute value of it. You don't have to graph it. Like I could go to Math 9, right, and do the same thing. So I just hit Math 9. We're going from 0 to 4. Math, Num, ABS. The function was x cubed minus 4x. Okay, and go back out here and type dx and press enter, and yay, it gave me the right answer. So that's one way around that with a calculator, you know, on a multiple choice test. That way, you know, you have to do all that work. You can just type it in the calculator. All right, so the other thing I'm seeing them give you is the area between two curves. Again, this can all be done on the calculator. So I'm going to share whiteboard. Let's go back to my whiteboard. And let's say I gave you two functions now. All right, so I'm going to give you, yeah, okay, I'll give you the function 2x plus 3. Let's just clear all this. And the other one, let's let the other one be, this, we'll call this f, and we'll call this one g, is negative x squared plus 1. And I want to find the area between the curves on the interval -1 to 2. Okay, So I'm going to graph these on a calculator. So all you got to do to find the area between them is basically the integral of the top curve minus the bottom curve. That's it. All right, and we can use our calculator to help us figure out which one's on top. All right, so I'm going to go into my calculator. I'm going to share a screen and put these things in the calculator. Let's see, new share. All right, so I'm going to go into y equals, and I'm going to type both functions. So one was 2x plus 3. And the other one was negative x squared plus 1. I want to know which one's on top in the interval that I'm considering. The interval that they gave us was negative 1 to 2. So I'm going to change x to go from negative 1 to 2. And we'll take a look at the graphs. All right, there's 2x, there's the first one, the second one. So it looks like the first one is always on top of the second one. It doesn't matter that the second one went negative, it's just the top minus the bottom. So the blue curve is the 2x plus 3, that's on top. So what we're going to do is we're going to set up an integral. Maybe I can share it on here. Maybe I can I annotate on here? No. All right, so let's change back. Whiteboard. So 2x plus 3 we had determined was on top. So what you're going to do is you just do the integral. The top was 2x plus 3. The bottom was negative x squared plus 1. Please put that in parentheses, otherwise you might lose a negative. And the limits they gave us were negative 1 to 2. So basically, I don't have to simplify that integral. I can just type it in the calculator, let the calculator do the work, and hopefully I'll get the right answer. When you do these, the area should always be positive. If it ended up negative, you probably have the curves reversed. All right, you have the one on top on the bottom and vice versa. All right, so I'm just going to go into my calculator now and do that integral. Let's see, am I sharing that with you right now? I'll make sure I am. All right, so I'm going to quit out of here, and I'm going to do math 9, and I'm integrating from negative 1 to 2. The top curve, which is 2x plus 3, minus the bottom curve in parentheses, negative x squared plus 1. Another parenthesis, there we go, dx. And then once I have it entered, just press enter, and yay, my area is 12. All right, so your calculator can be very, very handy for these things. Sometimes they don't give you an interval, they just want you to find the area enclosed between two curves. If that's the case, your calculator will help you figure that out. So let's do one more kind of more difficult example. But again, we're going to use the calculator because the calculator is so easy for this, okay? So let's say I gave you the function, a couple of functions. Let's see, y equals, let's do 2x cubed minus x plus 1, and y equals 3x. Let me make sure this will work. Let's just take a look at that graph real quick. Yeah, all right. So I'm going to enter both of these into a calculator. And the problem will say something like, find the area enclosed between the curves of, and this is about as hard as they could get, this particular type of example. So I'm going to take a look at it. We'll see why. It's not that hard, but all right. So I'm going to type both curves into the calculator. The first was 2x cubed minus x plus 1. And the second curve was y equals 3x. All right, so if I hit graph, I'm just going to zoom 6 this thing. All right, what you can see here, hopefully, is there are two areas enclosed beneath the curve. There's the blue curves on top first, and then the red curves on top. So you're going to have to split this into two integrals, but fortunately it's all calculator. So what I'm going to do, there are 3 places where these curves intersect, and I'm going to find them. So I can use my calculator. Second calc 5, intersect, and I'll go find the one furthest to the left. Whoops. There we go. Press enter 3 times. So I'm going to I get there for that first intersection. X is negative 1.526. I'm going to hold on to that. I'm going to go find the other 2. Second calc intersect. I'm going to go move so we're near this guy. So they intersect there. It's 0.259. And for that region, you can see that the blue curve is on top. So for that region, it's going to be blue minus red. All right, now I'm going to go find the other intersection. I'm going to move up here, press enter, enter, enter. So I get 1.267 for the upper one. So between 0.259 and you see the red one's the one that's on top. So what I have to do is set up 2 integrals because the top and the bottom change. All right. So I'm going to go to math. See the blue one's on top. Yes, I'm going to go math. Oops, I need to get out of the calculator, all right, math 9. So the first integral, the lower limit was negative 1.526. And the upper limit, the one where they both crossed, was 0.259. So on that first interval, the blue curve was above the red curve. You can go back and check it. The blue curve is the cubic. So we're going to do the blue curve, which is 2x cubed minus x plus 1. And we are going to subtract off the red curve, which was 3x. Now, if you get a negative answer for this, you picked the wrong top and bottom, just to let you know. All right, so dx. So there's the area. The first little chunk of area is 3.599. We'll call it 3.6 units. So I'm going to hold on to that answer. And now I'm going to do the other chunk where the red curve was on top. So I'm going to go math 9. And you're going to integrate from their intersection point, which is 0.259, to where they cross at the top, which is 1.267. And it's the red curve minus the blue curve. Be careful with parentheses. Red curve is just 3x minus all of the blue curve, so put it in parentheses. The blue curve was 2x cubed minus x plus 1. Right, I need another parenthesis. And then we're going to type dx. All right, so that area is 0.782. So what I'm going to do is simply add these guys together. A quick way to do it, go up, press enter, plus, go up again. I'm just arrowing up, enter, enter, and there's your area, 4.381. So again, the nice thing with the calculator, the definite integrals become super easy because you're just plugging numbers into a calculator. Hopefully that'll help you guys because, you know, on a multiple choice test, there's no reason not to plug those into a calculator. Now, the other thing I want to mention, if just kind of in passing, if they give you an integral of a rate, so let's say, let's do a business problem. Let's say I was integrating the marginal revenue, right? Which means it's the derivative from, let's say, 0 to 5. So you integrate a derivative, you get the function. So you get R. So you get R of 5, upper limit minus lower limit. What this represents, this is what they call the net change in revenue. It's how much the revenue went up from time 0 to time 5. So in 5 years, all right? Net change in revenue from t equals 0 to t equals 5. So understand that net change is how much it went up or down, hopefully up. It is not the same as a rate of change. When they ask you for a rate of change, you are looking for a derivative, right? So the thing there is keep the keywords in mind: rate of change, derivative, net change, integral. If they want an absolute minimum or maximum, that means take the derivative, set it equal to 0. So those are kind of keywords for word problems, and I just want to make you aware that that's really what an integral represents. All right, well, that's it for today. And I will come on and do another video where I found a sample final slug over that, okay? All right, have a good semester. All right, take care. Bye.